So we saw in the last video that we brought this rod near here and this guy got polarized. Now we're going to kind of exploit this polarization and use it to charge the sphere without actually getting any charges from here. So what we do is we ground this. That means we take a piece of metal that is connected to the ground, to the earth. It could be you touching it with your fingers, and your body is this wire which uses to send the electrons down to the ground. Now, I'd like you to think of the earth or the ground as being an infinite source of electrons. Would you agree that the earth probably has an infinite number of electrons, like just all the electrons you could possibly want? And also, the earth is a place where it will accept as many electrons as you want. So when you touch something to the earth, you make the charges disappear. We call this shorting. And it's not something desirable in most cases. You do not want the charges flowing to the ground. You want them flowing through your appliances at home. But in this case, we're just going to look and see what happens when I connect or touch this point or connect it to the ground. The negative charges that were over here said, hey, guys, or girls, there's a path to Earth where we can find all the positive charges we could possibly want. Let's get away from all of these, away from each other, really. And so they disappear and they just kind of zip down here. And so essentially, the effect of grounding something is making the charges disappear. We'll see this will happen even in the case of positive charges. No matter what kind of charges you have on that end, the part that you touch, you make those charges disappear. They're not really disappearing. We know the law of conservation of charge. They're actually making their way to the earth. Okay? If we look at a second picture here, well, now let's continue with this. So once I grounded this, those electrons left away. Now this thing is charged because it has more positive charges than negative charges. I don't need this guy here anymore. He didn't do anything in terms of touching this guy and passing any charges over. He just polarized him so I could short the other side. And so now when I move this guy away, I'm left with a charged conductor. So here's a way that you can charge something, and this is called charging by induction. Okay. Let's say, for instance, if this charge had been positive and negative charges were here and positive charges were there, when I would touch this here, electrons from the ground would run up saying, hey guys, there's some positive charges here we can go hang out with, more than the earth, which is so neutral. Let's get up there so we can be around extra positive guys. And so they make their way up here and they would kill all the positive charges that would have been here had I reversed the situation. So that's how it would work in both cases. So again, we had in summary, we have three ways that we can charge something: by friction, which is by rubbing; by contact, by simply touching so the electrons jump over; and through induction, where we polarize one part and then we touch the other side and make it go away. What causes lightning? Again, it's a buildup of charges. The clouds, in a sense, are rubbing up against each other. Um, Redistribute the charges. You have charge buildup on the bottom end of the cloud, and eventually they want to get away from each other. And they actually look at air as being a path to go through because there's so much charge it can push its way right through. And so you can kind of see a picture of this. This is all built up. This guy gets polarized. All the negative charges from here have pulled back down, leaving this positively charged, and we've got this huge desire for these guys to get over here, and eventually will zap through the earth and make it through. And there's some things about thunder, and pretty cool that the reason thunder causes this noise is because it causes the air to expand, and because you know about sound is that you expand the air in a real quick way, the air vibrates, and then that's some things about lightning bolts, how fast they travel, and about how many bolts hit the earth every day, and some myths, interesting ones to go ahead and read up on. Will rubber shoes protect you in a thunderstorm? No,